Hi students, welcome to my lectures on mechanical unit operations. Today we are going to discuss about standard sizes of the screens and screen analysis. What is the purpose of screen analysis is to find out the different size particles and different amounts. I have kept screens on the bench and it has arranged in a specific order. The one, example, I have mesh number 4, it is mesh number 6, mesh number 10, 20, 30, 60, 100 pan. These screens are arranged in a specific order. The mesh number with the lowest number should be kept at the top. The highest mesh number should be kept at the bottom. The last one beyond the 100 is called pan. It is just to collect the material. Why it is arranged in the specific way? Why mesh number 4 is at the top and mesh number 100 is at the bottom? Because what is mesh number 4 indicating about this particular screen is typically as per the ASTM or Tyler standards, British standards, German standards, mesh numbers are defined in such a way that mesh number 4, let us say 4, is indicating number of apertures per linear inch. Apertures means openings. Okay, every screen consisting of opening. What is mesh number 4 means? 4 apertures per linear inch. That means I take a 1 inch scale, I put it on the any place on the screen. In this 1 inch of length, how many openings are there or how many apertures are there? That means in this 1 inch, I have 4 apertures. That is why it is called mesh number 4. Okay. Similarly, the mesh number 6, what it is indicating? The same, mesh number 6 means 6 per linear inch. That means if I take 1 inch scale, I put it on the screen and it will measure 6 apertures. Example 1, 2, 3, 4, 5, 6. That means there are 6 openings per linear inch. Similarly, what is this 10 is indicating? The 10 is same. Take 1 inch scale and put it on the screen, measure how many openings are there. That means as mesh number is increasing, you can observe this is 4, this is 10. The size of the screens are reducing. That means more is the mesh number, lesser is the opening size. That is what the mesh number is indicating. Imagine this is 100. That means I'll show you how the 100 looks like. Okay, this is the 100 and this is the 4. Imagine what is mesh number 100. I take 1 inch, I put it here, the 1 inch, I measure 100 openings in this 1 inch line. That is how the mesh number is defined. So because, and this is how you have to arrange the screens. The one which is small should be kept at the top. What you do the reverse way, if you keep 100 here and 4 here in this way, none of the material will pass through because all the bigger particles remain at the top. So that is why always you have to arrange the screens in terms of the lower mesh number to higher mesh number. We will discuss on the board later that what are the other definitions for the mesh number, because once I go to the Indian standards, they define the mesh number in different way. And Europe, if you go to the South Africa and kind of countries, they use a different kind of mesh numbers. Example, sometimes the mesh number is in terms of per square inch. Okay, what is this per? Because till now we have discussed about the linear inch. What is the square inch? Mesh number 4, as per the South African standards, kind of 4 per square inch. That means I measure 1 square inch area. That means 1 inch by 1 inch means 1 square inch. In this particular area, how many openings are there? That is my mesh number. 4 means in this 1 inch area, there are 4 openings. That is how the mesh number is defined for certain standards. And if you go to the Europe, they measure in terms of square centimeter. That means take 1 centimeter by 1 centimeter area and measure in this particular 1 centimeter by 1 centimeter area how many openings are there or how many apertures are there. That is how the people define the mesh number in different ways. I'll discuss about the Indian standards on the board. Okay, let us go to the board and discuss about the mesh number and with the calculations and so. And thank you. But before that, once you know the mesh number, that means 4. If you know the mesh number, you can able to tell what is the diameter, because there is a formula connecting mesh number and diameter of the opening. Okay, we will discuss it and wait for it. Hi students, let us discuss about the mesh number in detail. As you can see on the board, I have divided the mesh number into 2 categories. One set of category follow a typical different definitions. The one on the right hand side, it's called the Indian standardization. Okay, let us go to the mesh number, which is defined M as per the definitions. As just now I have discussed about the mesh number is number of openings per linear inch or per square inch or per square centimeter. Number of apertures per linear inch, this kind of standards followed by, typically these are the ASTM standards. They follow this definition. ASTM, Taylor series, Taylor Co, British standards, German standards, which is DIN. All these standards will make the screens as per the definition given. Okay, number of apertures per linear inch. Once you go to the South African countries kind of, and it is defined in such a way, it is number of openings or apertures per square inch. That means these are the people typically follow the square inch kind of idea. And the number of apertures per square centimeter typically followed in Europe countries. These are the definitions. As I told you that once mesh number is specified, diameter of the opening we should know. Okay, there is a formula connecting the mesh number and diameter of the opening. The aperture size or opening size D, capital D, equal to 1 by mesh number minus D. Typical D is we have to remove the thickness of the wire in our measurements. That is why we have to remove it. 1 by M minus D. Example, find aperture size for mesh number 4. Given wire thickness D equal to 0.07 inch. As per the definition, M is equal to 4 per inch. Okay, mesh number 4. D is 0.07. If I put it in this formula, my opening diameter is 1 by 4 minus 0.07 inch, which is 0.18 inch. That means mesh number 4 screen has got the opening diameter of 0.18 inch. Let us continue the example. Example number 2. Okay, just now we have done the mesh number 4 having the opening diameter of 0.18. Similarly, if we do the calculation, mesh number 6 has got the diameter of 0.09. Mesh number 10 has got the diameter of 0.03 inch. These are the, what is the typical trend you have observed here? If you increase the mesh number, the diameter of opening is getting reduced. That is why it follows the reverse trend. Increasing the mesh number decreases the opening size of the screen. Higher is the mesh number, smaller is the screen, opening diameter. This is typically one set of definitions. Let us go to the Indian set definition. What is mesh number? For example, mesh number is equal to the aperture size itself, adjusted to the nearest decamicron. It's very simple. Don't get confused with the definition. Mesh number is equal to aperture size. That means given mesh number 100, aperture size is also 100. 100 is of what unit? 100 is the mesh number, means 100 is the size of the opening. What is that unit? 100 is decamicron. That means if the mesh number is 100 Indian standards, that means 100 decamicron is the screen size, opening size. 100 decamicron means 1000 micron. That means 100 into 10, that means 1000 micron. 1000 micron means nothing but 1 mm. That is what the simple. 100 mesh number means 100 decamicron. 100 decamicron means 1 mm. What is the typical 200? 200 mesh number means 200 decamicron. 200 decamicron means 2 into 1000 micron. This is nothing but 2000 micron means 2 mm. That means it is directly giving you the mesh number is equal to the aperture size. What is the typical trend it follows? 100 means 1 mm, 200 means 2 mm, 300 means 3 mm. What is the trend is following? Increasing the mesh number 100, 200, 300. Diameter is also increasing 1 mm, 2 mm, 3 mm. So that is what this two arrow indicating, because which is different from this set of definitions. You can see here, as the mesh number increases, the diameter is decreases. Okay, here the mesh number increases, diameters also increases. This is the typical standardization of screens. Okay, and let us go to the next set of example, which is called screen analysis. That means now you know how what is the diameter of the screen, and now we have to go a bit further, that find what is the purpose of screen analysis. Once you've done the screen analysis, that means you have kept some materials on the screens, you have shaped it, and on different screens different amount of materials will sit on the screens, and we have to define its sizes. What is the primary agenda of the screen analysis is to find out the sizes and their amounts. Okay, thank you. Let us go ahead for for the next set of lecture.